And this will be dealt with three of us, me, myself, Professor Argoti Bishwas, then Professor Obedur Rahman and Professor Narayan Roy. Obedur has already introduced the introductory part of Geotechnical Engineering 1. I'll be repeating the same thing, few parts of the thing, and then we will move the main domain. Okay. See, as Obedur has already mentioned, we should know why we should uh, deal, discuss a topic, and what is that topic all about. See, our civil engineering is consisted of, at least the concept of this consisting of several specialization exist around 15 years back. At that time, 15-20 years back. At that time, this specialization or division of civil engineering was much prominent as of as compared to at present days. See, our civil engineering is developed from that moment, very first moment when this art has seen that civilization. So, as it has started with civilization, it will be ending.
Yes, sir.
Hello,
Hello, sir. I'm Niloy Ghosh. Sir, one of the students named Indojit Mondol is trying to join, sir.
what I can do? I mentioned I won't allow anybody without that invitation.
Sir, actually, he might not have got it.
That's not my problem, and don't disturb me within my lecture. That's your CR's problem, and deal with him.
Sir, I am the CR of the section B.
Then it's your fault.
Sir, actually,
I won't. I won't. When go back to that screen repeatedly. That's a problem for me. That's a flow breaking, and you are doing that one. When you are the CR, you should have that responsibility that everyone should have the access. So civilization. So the civil engineering has started from the moment, very first moment when the civilization has started, and it will be there, the civil engineering, when the very last moment of civil engineering civilization will exist. So civil engineering as of 15 years back was consisted of these five specialization. One is structural engineering, then geotechnical, environmental, water resources engineering, and transportation engineering. Among these five, the structural engineering was very much popular and important in around 15-20 years back. But thereafter, as our complicated civil engineering or civilization has expanded, the infrastructure has grown up with a very complex mode. The other domain has come into the picture gradually, more prominently. And nowadays, we merely have any such distinct feature of civil engineering domain, but we are having several of such feature in combined mode. And therefore, if you look into the present academic scenario, the departments, they are having several of schools which consisted of several of such specialization. Once upon a time, those were called specialization under a same department. But nowadays, schools are being forming, having more than two or three specialization combining a school. Okay. So, like the structural engineering, geotechnical engineering, they have combined the earthquake school of earthquake engineering in several NITs or IITs, right? Like geotechnical engineering, environmental engineering, they have several things like geo environmental engineering. biogeotechnology, like geotechnical and transportation engineering. They have some transportation geotechnics, and many such things exist nowadays, right? So gradually, the importance of structural engineering, they haven't reduced, but gradually the other part of the civil engineering has come more prominently uh, by side the structural engineering. Okay, at our times, the transportation engineering means only you just build the road, vehicle will move. But nowadays, the concept is totally different. We at least not the Indian people, but outside, if you see the USA or Europe, they have transportation engineering more prominent at present as compared to any other specialization of civil engineering because of the infrastructure development. A proper planning regarding the transportation network, a proper traffic planning, signaling, all those things actually makes uh, the riding, the safety of the riders, the safety of the vehicle, all those things comfortable as well as safe. That's why when you will visit some of the abroad countries, and when you return back to our own country, you'll feel those things are much better, and we should have developed ourselves alike, right? So this is about the civil engineering and their different parts, specialization, so called. One of the thing is geotechnical engineering. Now, why we should deal with geotechnical engineering? See, this term of geotechnical engineering doesn't bother civil engineering about 30-40 years back. But thing is that gradually, when this civilization has expanded, we need complex infrastructure like metros, like underground tunnel projects. That tunnel could be metro, could be some your goods transports, maybe water, electricity, all those tunnel things. Some of the things are overhead communication like ropeways, and of course that uh, superstructure building, roads, bridges, all those things. They ultimately has to be supported by the soil. Now the term soil actually I means the layer, the outermost layer of earth, which is we are looking at, we are interested about 100 meters from the ground surface, which actually contain all those civilized or civilization, that structure that's they actually provide the support to that civilized structure. Okay, so every structure on the earth has to be built on that soil, that part of the earth, as well as they has to be rested safely, comfortably, and their this existence should last long. Okay, and during their service period, they should not behave abruptly. Okay, so this is why we should have a proper knowledge about that earth behavior or the soil behavior upon different kind of loading. See, the loading could be simple vertical loading, that a building has to be built on. When you will be building a simple one-story, two-story building on the earth, it will be a vertical loading straight away, right? Now, if that building is subjected to wind load, that is the lateral load, then you will have a moment. The soil should have that capacity to resist that moment as well. Now, if that building is subjected to earthquake, then you will be having a shaking kind of loading. Now, that building should have a compatible foundation to resist that shaking as well. I am not talking about the superstructural thing, that is concrete, steel, all those things, but I am only looking for the ground system. So there will be several kind of loading, not like this shaking or wind load. There will be some water accumulation. There will be some seepage, water force coming from bottom. So everything, every kind of disturbance, our soil system or where you have founded the structure, superstructure, That foundation should be adequate enough to resist that kind of disturbance or outer movement loading. Here a very brief summary of the geotechnical engineering, which is being associated with several other civil engineering domains like structural engineering, transportation, construction, environment, earthquake, hydraulic, mechanical, as well as some of the feature is very much associated with geology. So every aspect of our day-to-day life is associated with soil, is associated with geotechnical engineering, right? Therefore, we should know where we are standing. We should know where we will be building a structure for us. We should know where we will be moving our vehicle. We should know if we are moving through metro tunnel, metro things, underground movement, then how that will be a safer movement for us with respect to geotechnical engineering or soil. Okay, so every aspect of civil engineering is associated with geotechnical engineering, is supported by geotechnical engineering. So that's its importance. But thing is that unfortunately, I'm talking about 30-40 years, but before that, let's say about 100 years ago, uh, geotechnical engineering was not in the picture. Everything with respect to some failure like tilting, like collapsing of structure was taken as just act of God. Okay, like it's a very classic example that Pisa Minor, it's being tilted. Nowadays, that tilting is being restored and it is within 1 degree, like, but it has tilted a much more once upon a time. But thing is that at that time when it was tilting, at that time it was taken as act of God. People haven't searched for the reason. When they have some similar such failures, similar such serviceability failure condition, the failure in terms of not collapsing the structure but serviceability as well. What this serviceability means the reason for which you have built a structure. If the structure is not able to serve you for that reason, then you can mention it as failure with respect to the serviceability condition, right? So not only the collapse but also the serviceability condition regarding several such instances forces people to look into that fundamentals or look into the mechanism for which these are failing, and searching that reason gives you the geotechnical engineering domain. Initially it was soil mechanics and foundation engineering and rock mechanics. Gradually it has combined the soil mechanics and rock mechanics. That becomes the soil mechanics or soil engineering, and in addition to its application, the soil science or rock science, in addition to their application, the whole domain is now termed as geotechnical engineering, right? Now, the gradual this is the cover this is the introduction which actually gives you a glimpse of how the civil engineering as well as the geotechnical engineering has evolved. The things is being uh, distributed into 4 5 phases, like pre-classical phase, which is about 800 AD, 800, sorry, okay. Then classical soil mechanics of phase one, classical soil mechanics phase two. Then comes the modern soil mechanics. From this modern soil mechanics onwards, people actually explore the geotechnical engineering or soil mechanics or foundation engineering or rock mechanics, whatever you can term. This 1910 onwards, people is rigorously working with geotechnical engineering as a whole. They have explore the geotechnical engineering from the bottommost point of its origin, from the topmost structure. Okay, then comes the geotechnical engineering, when people have combined the soil mechanics and rock mechanics, that is around 1930. Okay, so before that, this classical soil mechanics portion, people have analyzed this geotechnical engineering or soil mechanics, rock mechanics. They have more these things, this soil mechanics. This was more conceptualized like solid mechanics as well as fluid mechanics. But the soil is not a solid body. It actually consisted of solid soil solid, that is the granular part. It actually consists of fluid within that granular part, and as well as it consists of void spaces or air spaces within that body. So these classical soil mechanics, people have analyzed the soil as soil solid, or it has been introduced as a fluid, fluid flowing through soil solid. So this phase one and phase two, they actually mostly those are the numerical analysis, numerical formulations. But the actual behavior, how the soil is behaving as a combination of solid, water or liquid as well as gas, that has been explored after 1900 years. Right? So this is about the historical development of soil mechanics. You can have this historical perspective from B.M. Das book, the book authored by B.M. Das, the book authored by Lambert Whitman. These are two classical book, or the Murthy book. Okay, VNS Murthy book. So these three books, you can have a glimpse of this historical development of geotechnical engineering, and I would like to suggest you at least go through that 5 6 pages to get a initial development, why and what was there in that periods of development regarding the geotechnical. After 1930s, people like Terzaghi and Atterberg, all those people, those are like giants in soil mechanics. They have almost explored everything. At least they have initiated that exploration, and nowadays we have a lot of information regarding soil mechanics, so that the failure or the complex structure that easily can be analyzed. Okay. Uh, Regarding the origin of soil, soil actually originated from rock, and from that it has been degraded. It has been mixed with something, these biodegradable elements, and there are several physical chemical reactions are taking place, so that the soil, as of where you are standing, if you just take some amount of soil in your palm hand, so what you will be seeing a blackish kind of solid, a moist feeling on that solid, and some amount of void spaces within that body. So that solid comes from the rock as well as biodegradable elements, right? That rocks, they have some mineralogy, they have mineralogical composition, and that will be propagated to that soil properties as well, right? It's like our ancestors. We are carrying the properties of our fathers and mothers. So every soil, they will carry their origin. They will carry their rock properties, and they will behave like that, right? So we will study the origin of soil, like rock cycle and occurrence of soil, then clay mineralogy and basic physical properties. Well, what are the basic physical properties do implies? See, you don't take this soil mechanics as an engineering subject. You take it as just a language. Every language, even our mother tongue, either Bengali, English, Hindi, or any other language, every language do have some letters, right? Those letters combining with others means several of such letters make some word. right? Several of such word, if you position it in a right direction, they can make some sentence, and such sentence combination of several sentence makes a paragraph, which actually defines or presents your mm, thinking, right? So it all about starting with letters, then words, then formation of sentence, then formation of paragraph that will express your thinking thoughts. So that expression of your thinking or thought is that ultimate behavior of soil, ultimate behavior of supporting structure. Supporting structure means the structure which is built on earth, and behavior of such foundation or building supporting system. The soil mechanics also do have some lettering. That means we will define some of the properties. Right now, you can say, sir, how we will define? It's a definition. Like the letter A. Who said it will be that upright position? It could be a V shape, right? Or it could be a dash, simple I kind of shape. But we have defined A like that. That we are seeing here. So based on that definition, we have make our words. We are making our sentence. We are making our paragraphs, right? And all over the world, the A is stands for A. That means that specific structure, specific uh, structure, drawn structure is similar to all over the world, right? And therefore, when you are writing apple, that apple is going to be is going to express the same meaning who is sitting on USA or UK. So this is a general nomenclature, you can say, common nomenclature that we will consider for basic physical properties or lettering of geotechnical engineering. Right now, we will define some basic physical properties that will hold good for paragraph writing, that will hold good for defining any behavior, soil related behavior. Then we can form some words, one or two or more than two basic properties will give you a complex property like word. Then we can make a sentence. Several of such basic properties can define a basic behavior of soil. Then we can make a paragraph. That means several of such basic behavior can develop a basic that can develop a paragraph, can develop a complex structure. Like ABC of soil can give you the properties of soil. From that properties of soil, one or two properties of soil, you can measure the uh, word or complex behavior. Ultimately, when you are writing a paragraph, just similar to digging a hole, underground hole like metro channels, that is a complete behavior with respect to such letter, with respect to such word, and with respect to such sentences. So it's very important that the behavior has to be defined with a unique and common, or you can say just general properties, general nomenclature throughout the world, so that every behavior can be understood by the people sitting all over the world, right? Okay, now what is soil? Soil mechanics and geotechnical engineering implies to us or defines everything. See, as Obedur was mentioning, soil is giving a different impression to different people. Right? People like us who are mostly dealing with 50 to 100 meters from the ground top surface, and we are mostly dealing with the effect of disturbance which will be applied on that soil. So we are mostly looking for stress strain behavior of the soil, whereas a geologist, they will be looking for the mineralogical composition, they will be looking for the generation of that rock, the origin of that rock, and their other properties. Like agricultural people, they will be their soil is within 4 to 5 feet from the top. They are mostly dealing with the crop production, right? Crops. So a soil is going to be treated different way by the different persons as per their requirement. So in our case, engineering purposes, the soil is defined as the uncemented aggregate. Uncemented aggregate means you can you can just separate out the soil solids. You can separate out the soil liquid within the soil. You can separate out the gaseous portion of the aggregate. Right. Therefore, it is called the uncemented. Right. So it is an uncemented aggregate of mineral grains, that is the rock grains or decomposed rock grains with decomposed material, and decayed organic matter, that is the solid particles. So what are those solid particles comprised of? It comprised of mineral grains and decayed organic matter with liquid, mostly in our case it's a water, and gas, that is the air, which are within the empty spaces between the solid particles. Right. So this is our definition. This is what we do understand with respect to the soil term. Okay. It is obviously the very basic environment construction material. It will start from excavation. It will start from filling the excavated portion. It will start from brick material as brick. In our village portion, it is mostly the entire constructional material, which will build the walls, which will build the roof as well in case of building construction. So it's a very basic and universal constructional material, right? In case of civil engineers, its origin, the soil's origin, grain size distribution. Grain size means the particle size, shape, and their proportion within the soil mass or aggregate. Ability to drain water, how easy the water or the liquid portion can be extracted, can drain from that aggregate. Compressibility, how compressible is that? That means if you apply stress or pressure from both the side, com- how much volume will be reduced from that normal situation. Shear strength, if you apply some shearing force to that soil, how it will resist your application of load or application of force, strength, stress, and ultimately the load bearing capacity. That is, if you build a superstructure on the soil, how much load, how much weight it can bear without having any failure. See, when I am talking about the failure, this failure consisted of either bearing capacity or shearing failure or settlement failure or both in combination. What is bearing capacity? That means your capacity to take, let's say, 20 kgs in your head when you are carrying the thing. If someone is putting 40 kg, that will be, you will be collapsed. So it's not your bearing capacity. Your bearing capacity is 20 kg. So that is load bearing capacity. Now let's say that is the maximum load bearing capacity. Let's say I have kept 15 kg on your head. So that 15 kg will give you some sort of stress within your body, and you will be just bent. Your backbone will bend. So that is kind of reduction in vertical height. Your vertical height, that is settlement. Okay. So these are the two conditions, that is bearing capacity and settlement, that we are looking for to construct any of the superstructure on the earth. Right. So these are the main feature that we are looking for as geotechnical engineering or civil engineers, like origin, grain size distribution, ability to drain water, compressibility, shear strength, and load bearing capacity. These are the major parameters we will be dealing with, we are looking for. Now, what is soil mechanics? It is the branch of science, of course, it is a science that deals with the study of the physical properties of soil. Soil means what we are seeing, the soil. Okay, as civil engineers, the soil. physical properties of soil, and the behavior of soil masses subjected to various types of forces. See, this is a very important phrase, behavior of soil masses subjected to various types of forces. A soil may be comfortable, may feel comfortable with a type of loading 1, but it is very much, maybe very much weak in type 2 loading. So its bearing capacity, its behavior, its strength is all depending on the type of loading that it will be experiencing. So it is a force dependent behavior, it is a disturbance dependent behavior. It's not its behavior, a soil is not will not behave in a similar manner for all kind of forces, all kind of loading, all kind of disturbance. Please remember that one. What is soil engineering? It is the application of that soil mechanics, application of soil science to that practical problems. Like all the engineering definition, it is the application of that specific or corresponding branch of science, right? What is geotechnical engineering? It is the sub-discipline of civil engineering, as I was mentioning, that involves natural minerals found close to the Earth's surface. See, this term close to the Earth's surface, at most we are going around 100 meters. Okay. It is the subdiscipline of civil engineering that involves natural minerals found close to the Earth's surface. It includes the application of the principles of soils and rock mechanics. So the basic thing is soil and rock mechanics that combines the geotechnical science, you can say, and their application you can term as geotechnical engineering, right? This engineering could be applied in foundation, that is foundation engineering, in retaining structure, that means when you are supporting some backfilling, just if you are considering, let's say, okay, leave it. The retaining structure means the structure which will contain some amount of soil or something at its backside. The other side will be free. Some other earth structure like embankment, like tunnel, like any filling or cutting, and several of such kind of civil engineering structure, which of course everyone will involve the soil as a founding material or as a supporting structure. Okay.
Sir, can we consider dam as a retaining structure?
Of course, yes, it is. Dam is of course a retaining structure.
Okay, sir.
So this is all about the basics of soil science, basics of geotechnical engineering, how or what we will be dealing in the domain that is defined here. Okay. Now, I have kept some of the figures that will give you some sense, pictorial sense, which involving the geotechnical engineering. See, my left hand side, it is the foundation straight away. Uh, Mostly in 30-40 years back, people, what is soil mechanics or what is foundation engineering? This is soil mechanics or foundation engineering. The left hand side, it's a pile foundation. Pile is a slender column which will be inserted into the soil to take some amount of load, which is not in generally beared by that near about soil layers. Uh, Anyhow, the left one is our typical foundation engineering, which consists of pile foundation. See the rightmost one. Can you see my pointer, mouse pointer?
Yes, sir.
Okay.
Yes.
So this right portion is an important feature, which almost, at least for me, uh, I was unaware about this kind of foundation. See, this is a foundation for tanker, the petrol pumps, the gas stations, or the underground gas station or petrol pumps. Those actually constructed underground, and they have a typical, as well as they have different kind of foundation, which is not according, not like our building foundation. See, This pipeline or this underground tankers, if you consider the underground tunnels, pipelines, they have different sort of foundation. Their consideration, their this founding behavior is something different than our this left hand side foundation. This foundation, these tankers, or let's say this pipeline, they have a very long stretch, right? And maybe a kilometers long. Okay, let's concentrate on our pumping stations, fuel pump station. They have large this kind of structures, right? This kind of oil tanker, which is just built underground. Now, the length of such tanks are several meters, like 20, 30 meters, that long. And thing is that the soil is very unique material which do not have any such homogeneity, isotropic behavior, all those ideal consideration that we can consider in case of metal like steel or concrete. But every point on the earth, the soil do possess a different characteristics. Now, thing is that this 20-30 meter stretch foundation for a oil tanker is a different kind of mechanism. Like when I was in my master degree, one of my friend, he was in Indian Oil. So they were having a typical problem regarding that underground oil tanker, this metal oil tanker. Okay, what they are having the problem was that whenever they are building a this kind of oil tanker underground, one of the side of the oil tanker gets expanded. So what will happen if you have, let's say this is 20 or 30 meter long stretch. Okay. Now if this material is stiff enough, okay, that's fine. Otherwise, if it is not strengthened enough, not stiff enough, then if if soil is pushing that particular tanker from that side, they will be tilted, and they will be tilted, affecting its stability, affecting its structural integrity. They can crack from the bottom like that. If it is made of concrete, then that problem will be very prominent. The concrete cannot take any tension. So whenever you are having some movement in either side, either upward or downward, you will be having some bending. Whenever you are having some bending, you will be having some tension at one face of the concrete. And whenever you have some tension, then concrete is subjected to crack. So this is kind of collapse. This is devastating behavior. Therefore, because of that, you do not have any what is that? What I should say? Any guarantee on that soil behavior for a very long stretch. Therefore, these underground structures, these tankers, they are mostly made of steel, metal, which can resist the tensile stress. Nowadays, people are building this. This is not all. People are not putting the metal pipe like that only. They are covering that metal pipe with jackets, concrete jacket. That means over that metal body, they are putting very thick concrete layer. That concrete layer is not ordinary concrete. I was involved in some of the project which actually dealt with this water tanker, water supply, starting from Polta Waterworks to Tala tank, Tala. Okay, it was built almost 11 meters down the ground surface. This that pipeline was, its basic material was steel. The thickness of steels were probably several of millimeters, 25 millimeters thick steel pipelines. Over that pipeline, that means outer side and inner side, we are having some layering. The outer side we are having the concrete layer. That concrete layer was around 100, 120, 150 millimeter thick, and below or inner side we are again having some mortar layering and then a special paint. The strength of that paint was huge. So that was the whole structure, whole thickness of that pipeline. See, and that concrete work used as jacketing, that jacket, that concrete strength was not an ordinary concrete. Its strength was around 50 or 60 M50 or M60 grade of concrete, and it was very difficult to achieve that M50 or M60 grade concrete. Okay, it was specially designed. It was specially designed concrete. So anyhow, this is a typical foundation, and this foundation is very difficult to assess. Its expansion, its compressibility, its moreover its uniform level, making the uniform level throughout, ensuring that uniform level throughout the design life, right? So this is a typical geotechnical engineering that you will be facing. So this one is everyone, almost everyone has seen. This is the abutment, flyover, and this one is your approach way. Here you need a huge amount of geotechnical specialization. See, this portion is mostly earth field or the soil field portion, and it is having a very high gravity mass that has to be taken care of by that supporting media, that is soil, underground soil. So it is having two components. This geotechnical, one is to stabilize that earth filling, that panels, that concrete panels. This is also coming under the geotechnical engineering. And the second portion, the entire thing has to be supported by soil without any settlement. Just see, let's say this portion and that portion, it is almost half a kilometer. Okay. During its service period, let's say this portion, it do not have any settlement or any upright movement or downward movement. But this side, it is having some downward movement. So what will happen? It will settle down even maybe 10 millimeters. So this settling down will affect there. It will have some cracking. And once it has happened, this settlement, the entire bridge has to be abandoned. It cannot be used. Okay, so it is a very high amount geotechnical high amount of geotechnical engineering involved there. Recently, 1 or 2 days back, I was in a discussion with Indian Geotechnical Society forum. There, some of that expert has mentioned some structural engineer. Okay, uh, the terms at moment may not be known to you, but just listen to the case study. Such structural engineering who has designed this portion, that superstructure portion, he has preferred one particular test which is called plate load test, which is obsoleted in USA or Europe, but still in our country they are prescribing that one. But thing is that why the abroad people have obsoleted? The reason is the structural engineering, the test he or they have uh, prescribed, the test reflected the soil is excellent. It can take any such this load, this superstructure very easily. But thing is that when you explore the underground structure layering by digging, by making some boreholes, they found if you just listen that structural engineering, and if you are building uh, that superstructure, it will collapse even when you have built up to this point, maybe one third of that bridge. Okay, so huge geotechnical expertise is involved there. It is not a simple mechanism that it looks like. Okay, Then this many of you might have seen. This is a hilly road, where you have some slope stability problems, that earth movement. Okay, it's called in our normal life it's landslide. See, you can see such some net kind of structure there. These nets are provided. These are called rock nets. Okay, these are provided to resist that this rock falling. Okay, I was in North Bengal for almost 7 years. During my staying there as assistant professor in engineering college, government engineering college, I was I was going for a site inspection with a vehicle. It's near about the most probably its location was it was towards Kalimpong, right? So one stretch, it's about half a kilometer. It was very much this rockfall prone stretch. I was sitting at the front of that vehicle. It was Bolero, okay, and just a size of cricket ball. That rock has hit when we were moving with the vehicle, and it hit just the front wheel, the top of the front wheel. The entire vehicle is just uh, it, some if you just see the vehicle, you will feel some bullet or gun has fired there, and it's just made a hole. You just feel it is something like a cricket ball, and what if it's something like a big boulder kind of thing? It will just wash that vehicle out from that almost half a kilometer height, and we will just at that Tista River, and it will be insufficient because I was not I won't be able to take your class for that reason. Okay, so this net actually very strength. These are very thick net, wire net. Is not like chicken mesh, but it is a wire net which is having very high strength wire net, and they are supporting these rock falls. They are supporting these landslides. Okay, these are very important structure in hilly region, and this kind of landslide is very much problematic in Sikkim side. The Sikkim side, this earth structure is not like a integrated or yes, integrated rock mass. It's a disintegrated rock mass which is filled up with silty soil. Now, when you have the rainy season, monsoon season, and these are just this silt portion is washing out, making the boulders or rock particles free to move downwards, and it's very dangerous. You see. So please avoid the Sikkim side in monsoon region if you can. Okay, these are typical thing nowadays. You can see this. This is a tunnel work or metro kind of thing. You have some. This is kind of retaining structure. You have supported the earth at its backside, and that supported portion you have built up office or some other civilized habitats. Okay, so this is a sheet pile, concrete metal sheet pile, which is supporting the backside of this beard or free side, free area. And you can see here we are making some tunnels. That tunnel could be metro, tunnel can be anything. I don't know exactly what for it was building, but this is a typical geotechnical structure. You have some embankment there, which is stabilized by its own mass. But here you have some vertical cut. Due to that vertical cut, you have to stabilize the earth, which is at backside of this one by that sheet pipe. Okay, here you have three kind of structures. One is tunnel, then embankment, and retaining wall. This is a tunnel which is going through. It is a road project which is going through the hill, okay, like our Otol tunnel. It is going through that hill. So this is your highway. It could be the railway portion. I'm not sure, but see here, these are again a retaining structure. This perforation, you can just see these points, black points. They are actually kept open. They are kept open. These are the holes. They are kept open for the water percolation. When you have some water, like this is a hillside, if you have some rainy season, that rain will percolate within that soil body or rock mass, and it actually gives a huge pressure to that side slope, and that pressure sometimes becomes so high that the slope collapses. Therefore, what they have made, you just look the picture uh, minutely, you can see it is a step formation. This step formation makes this whole structure stabilized, as well as they made some holes through that steps. These holes actually allows the water to drain out, so that the water pressure should not build at backside, and that excess water pressure, which it's difficult to estimate how much water pressure is developing, because the water is percolating throughout the year, maybe years long, and how much accumulation is there at the backside, you never know. Therefore, how much water pressure is going to experience that, going to force that phase, it's very difficult to assess. And if it gets excess, then this phase will collapse. Just for example, if you go that North Bengal from this Malbajar side, this towards side, towards Darjeeling, towards Kalimpong, just before the Shevok, that Coronation Bridge. Initially, when I was there 7 8 years back, I I have seen a retaining wall, concrete retaining wall, gravity type. A retaining wall was there. That's other side, that Malbajar side of that Shevok Bridge. Hmm. That was stabilized. But when I returned from there, uh, maybe a year back, I have seen that retaining wall has collapsed. Now that collapse is due to that water pressure. Could be because this entire maybe decades long water accumulation has now become excessively high. So what they have made, they have just pushed the gravity retaining wall in the free side or road side, and once they are pushed, their utility is finished, just finished. So it's now just like a wall. It's standing. It's not now. It's not serving anything. It's just standing there. Okay. So geotechnical engineering is very difficult to estimate its behavior. There is another kind of thing. This is a dam, as someone has mentioned, whether it is a retaining wall or not. Yes, of course, it is a retaining structure. It retains the water at its back. Sometimes it's used as this what is that, electricity purpose. There are many purposes that it can be used. Even the top side can be used as transportation purpose, all those things. This particular figure, it actually considers the retaining wall, retaining side, as it is built on rock, so it involves rock mechanics. Okay, it involves fluid mechanics, it involves that water power. uh, okay. And these are very unique engineering, unique geotechnical. It's not entirely geotechnical, but it's a unique civil engineering concept here. So it's a very, see why geotechnical engineering nowadays is very important or in a focus, because of its uncertainty, because it's difficult to estimate or assess some behavior. The more the difficult the things are, people are more interested on it. Therefore, nowadays geotechnical engineering has become a prime object, prime specialization on uh, civil engineering domain. Okay, because of its uncertainty. Okay, it's a typical one. It's a canal. The canal side, this is the water. It's flowing through the canal. The water percolation is restricted by the sheet pile. Again, it is a retaining wall. And this side, again, you have a stabilization. The stabilization made of uh, it's a geosynthetics actually. This is soil engineering, geosynthetic or ground improvement thing. These are some geotextiles. Over that you have some aggregate stones, and that slope, this entire slope is stabilized with this is called what is that? Just forgetting the thing term. Anyhow, it actually having several purposes. Once this portion, this stabilization portion is completed, the sheet pile will be will take will not be there. We will take that sheet pile from there. Now what we will have, you will have water there, then this slope stabilization slope, bare slope. Now the slope is stabilized with geosynthetics, with rocks. That rocks or geosynthetics will allow the water to percolate through in either direction, but it won't allow the soil to be washed out through that portion into that canal. So canal will be safe. The soil behind that protected area will be safe. So this is how we are making our ecology safer. Ecology exists there. It will not be disturbed. Okay, fine. Okay, this is another one. This is a mining site where you need to stabilize the slopes. These are the mining where you are excavating the soil and then you are depositing there. So that deposition do need this slope stability aspect, as well as the huge gravity mass has to be taken care of by the soil which is underlying there. Remember, this is not all about, but when you are supporting this huge amount of soil, it will put from that bottom, it will push the it's called the bearing capacity problem. When the bearing capacity problem comes, this soil from the underneath that ground surface will be pushed laterally to that side, and that will cause the collapse of side walls of that excavation. So you need to have a stabilize that side walls as well. So it's a typical or unique geotechnical engineering where you have excavation. That excavation, that side walls of that excavation has to be stabilized. That is a geotechnical problem. Then you have deposited the excavated soil. The slope of that filling has to be stabilized. Then it is again geotechnical engineering. The excavated soil mass has to be supported. This is a bearing capacity kind of thing. So bearing capacity, again, it is a geotechnical engineering. So several sub-disciplines or sub-specialization of the geotechnical engineering is existing there, right? Okay, so this is the typical geotechnical things that are explained there, other than our normal foundation or normal building. So this is a very brief of geotechnical engineering, development of geotechnical engineering or historical perspective. Like pre-classical, most of the things were based on experience, just like act of God. Then you have the soil mechanics, phase one and phase two. In phase one, you have Coulomb, you have Navier, you have franchise, all those things. They have Colin Rankine, whatever the theories they have explained, they have proposed, all are almost mathematical or numerical. Okay, based on mathematics mostly. No. In phase two, we have Darcy, Darwin, Boussinesq, Renaud. Again, the things are mostly mathematical, the expressions. But in phase two, you have some kind of granular involvement, granular particles. Soil in phase 2, soil is not entirely taken as solid body, but some of that people like Darcy, Darwin, Wozniak, Renault, they have considered soil as some disintegrated material. So phase 1 and phase 2, they are gradually they have considered the soil as granular material, but all the expression mostly mathematical, right? Now comes the modern soil mechanics. It's all about the Atterberg, Bale, Felenius, then Terjagi. Terjagi is called father of soil mechanics. There is nothing left that he hasn't touched. Therefore, Carl Terjagi, he is called father of soil mechanics. But the thing is that you will learn afterwards. Before coming to Terjagi theory or Terjagi's things that he has considered, the other thing, this Atterberg, this person has actually proposed the plasticity concept of soil, the consistency or the degree of firmness of soil that I will explain later. Unless that concept is introduced, the Terjagi theory or Terjagi thing is difficult to assess. So, if for me, entirely is personal view, if Terjagi is called father of soil mechanics, Atterberg should be called grandfather of soil mechanics, because the initiation was made by Atterberg himself. Carl Terjagi is the founder of ISSMFA, which is an international body, International Society of Soil Mechanics and Foundation Engineering, which later on is named as International Society of Soil Mechanics and Geotechnical Engineering. It's a international body who, like our Indian Geotechnical Society, it is a geotechnical society of several countries, and it is an international body who actually develops different standards and all those conferences, lectures, all those things. So it is a uh, international body, center. So what are the things Carl Tarjagi has proposed, touched, postulated? The concept of effective stress, shear strain, cone penetrameter, all those things. Uh, I just forgot the country he belongs to, but the setup what he has made almost 100 years back, the setup, those things are still working, and and the result it is producing is still far better than our modern equipment, some of the modern equipment. But you will just you cannot imagine he has used this what is that, the wheel bicycle wheel to apply loading on consideration of it. So it's a very small equipment, or the equipment which do not have any relationship with civil engineering or soil mechanics. He has used those things to develop with this is something like gear and lever arrangement. It's a very I just forgot the country and the location. If I can take those pictures, I can have those pictures. I'll search for it. I'll send you. You just look through once that how simple the mechanisms are, but how important the things, the outcomes are in relation to soil mechanics. Okay. So this is how the soil mechanics has developed. Afterwards, the path that has been shown by Terjagi, the paths are followed by all of us, several of our other giants like Skempton, who has defined the pore pressure parameters, Bishop, Henkel, Peake, Casagrande, Taylor, Bijenam. They are just like giants, gods of soil mechanics. So you will have their contribution. You will get their contribution in sequential manner. And actually, we at present, whatever we are taking as our research topics in geotechnical engineering, the topics actually defined initiated by these people. We are just altering few of the parameters and we are taking the modified response. But the basic thing was defined by these people only. Okay. So let's start with the origin of soil. It has been originated from rock. The rock is mainly divided into three categories. One is igneous, sedimentary, and metamorphic. The igneous is the parent rock, you can say. From igneous, everything is propagated. See, this is called rock cycle. This one is called rock cycle. So what you have magma, then igneous rock. Then from igneous rock, you can have some metamorphic rock. You can have sedimented rock. From the sedimented rock, again you have sediments. Again you have sedimented rock, or again it can return back into that loop to get again further sedimented. The sedimented rock can have the form of metamorphic rock with the pressure and temperature. This is called the rock cycle. So the possible ways of conversion is shown here. In general, soils are formed by weathering of rocks. The physical properties of soil are dictated primarily by the minerals that constitutes the soil particles. Like us, we are our properties, our nature, our behavior is dictated by the behavior of our parents. Just like that, our father, mother, and sisters. So this is just like that. The physical properties of soil are dictated primarily by the mineral compositions of that soil particles or the rock from which it is being formed or derived. So I am not going into the detail of this weathering process or the processes. You just go through your 10th or 12th standard book, the geography book. You can have the details there. But I am just making a brief presentation for that. This weathering, all the rock formation, soil formation, all those things. Please go through the book carefully. This part I am not going into the detail because time may not permit. If it permits later on after completion, then I will return back to it. Or if you read it from any of the textbook, if you have any doubts, you can put your doubt on that WhatsApp group that we have formed. You should put there, not in my personal message, because maybe one thing is not clear to you. Maybe other people who are there, other your fellow students, friends, and they can use their understanding there. It is that group is mostly a discussion forum, and don't hesitate to put your doubts. It may be you are you should not feel shy to make your queries. Maybe everyone is having the same problem, but no one is making that query because of that feeling that I am the person who is only the person who do not understand. No, you just put your all queries in that WhatsApp group. Any of us, either Obedur, me, or Narayan, will answer you, or any of your friends can also answer that particular doubt. And it should be used at a discussion forum. Okay. So igneous rock, it is nothing but solidified molten magma, and its property is defined by the composition of magma and the rate of cooling. So it's a very important parameter, the rate of cooling, how fast the cooling process is taken place, and it made that rock. See, our glass works like glass. Every glass thing, the glass is not a solid body. It's a solidified liquid. The solidified liquid, it means when it is a melted form, it's suddenly taken into a very low temperature and it solids. It becomes solid. So it's called solidified liquid. And that lower temperature may be room temperature even. If you are melting that particular body at the temperature of 2000 degrees Celsius, for that 2000 degrees Celsius, 27 degrees Celsius is very cold, very cold. Okay, it's a kind of relative movement, relative temperature. So that rate of cooling, if it is instantly being cooled or it is having sufficient time, it has taken sufficient time to become solid, the composition of or the crystallization or its composition gets altered for that rate of cooling. Now, if the solidification happens below the Earth's surface, within the Earth's surface, then it's called intrusive kind of rock. If it comes at that ground surface, then it will be called as extrusive. Right? Now, sedimentary rocks, the deposit of gravel, sand, silt, and clay formed by weathering. Weathering may be physical, may be chemical. Weathering may become compacted by overburden pressure and cemented by the agents like iron oxide, calcite, dolomite, quartz to form rocks. Cementing agents are generally carried in solution by groundwater or even the flowing water, right, river. Hmm. So please go through the weathering process for formation this rock thing. The metamorphic rock, metamorphism is the process of changing the composition and the texture of the rock without melting. So it's a process which being dictated by pressure and temperature, but without melting by heat and pressure. During metamorphism, new minerals are formed and grains are shared. See, one example, this line which is saying cementing agents are generally carried in solution. That solution could be groundwater, could be the surface water. One example is our Duars, North Bengal. See, you might have heard the name Jayanti River, which is flowing through Bhutan as well as India. Okay. Now, at the Jayanti River, the Boxa region, the river bed becomes at very high altitude. It's so high, it's almost the river bed comes almost uh, past second story of a normal building. Now, this rise in riverbed due to that is a reason for that cementing agent. See, in Bhutan area, they have a deposit of dolomites, huge deposit. They have these hills of dolomite. Now, when they are doing that mining works, the wastes, which consisted of this bauxite, all those things, the wastes uh, are just deposited or they deposited this waste, this mining waste in that Jayanti River. Now Jayanti River, what it do, it actually made the solution of that cementing agent, that bauxite. This is which is nothing but our this plaster of Paris, all those that basic component. And when it comes at that plain region, when its flow gets uh, slower, it what it do, it sediments those solution. And by the way, the entire riverbed is just cemented like rock. And a few years back, when Indian people was trying to recover or trying to excavate that river bed to get that deeper portion, they are failed. They are using this JCB, these JCBs, but JCBs were unable to excavate that river bed because now the river bed has become several of meters thick rock like concrete, several of meters thick, and it has rise to a height almost first or second floor, maybe you can say 5-6 meters. Hmm. Now the river is flowing on the top of these surrounding habitats, the buildings, and the entire this Boxa Jayanti, that river zone, that zone is almost closed for visitors, closed for making those homestays or hotels because of that reason. The day will come when the entire Jayanti or Boxer River will be flooded. The entire this ecology will be destroyed because of that cementing agent, dolomites. It's a very unfortunate thing, but it's happening. And you cannot afford to close that mining because it is an international problem. Okay. Now, weathering, the process, what is weathering? It is a process of breaking down rocks into smaller particles by mechanical and chemical process, right? It's probably all of you has all of you is known to that weathering process. It could be mechanical or physical, or it could be the chemical weathering. Mechanical weathering, it is caused by expansion and contraction, simultaneous cyclic process of expansion and contraction of rocks, and which actually breaks down the big giant rocks to smaller particles, smaller parts. Okay, then seepage of water in the pores, which and existing cracks in the rock when it gets solidified, like your what is that ice, it expands and it actually breaks down that rocks. Others, it includes glacial ice, wind, running water stream, all those the mechanical or physical carriers forces that actually breaks down the rocks. Chemical, it is nothing but the decomposed material, decomposed chemical, leaching chemical uh, formed by the decomposition of our organic matters, which reacts with minerals of rock and gets formed. These oxides are formed, which are less stable, and the rocks are broken. Okay. So weathering process is not limited to igneous rock. It is not acting on igneous rock only, but it is acting on every kind of rocks, whether it is igneous, sedimentary, or metamorphic. Okay, right. The clay minerals, which are a product of chemical weathering of feldspar, ferromanganese, cyan, manganese, and micas, give the plastic property of soil. So these are the reason who impose the plastic property within the soil. There are three important clay minerals based on the available sources, based on the known type of soil. We have classified the mineralogical composition of soil. We have classified into three major groups. One is kaolinite, other is illite, and the third one is monzonite. This kaolin soil, you have seen this kaolin soil, type of kaolin soil. Like this is nothing but this China clay. We all use this China clay made plates, cups, all those things. So this is nothing but kaolinite. Illite and monzonite. Monzonite is a type of material, type of soil. It's called hydraulic mud. Bentonite. Bentonite you might have seen if you have seen some big drilling projects around your city, around your home, you will find when they are excavating, they are making such drills into the soil. They use some clay slurry, soil slurry. These soil slurry are actually constituted of the bentonite slurry, which stabilize the side walls. So this bentonite is a type of clay. It's formed in it's industrial clay actually. It prepared in industry with a basic soil material. We put some chemical composition, chemical part on that soil so that it will have some different composition. In natural formation of this monzonite or elite type of soil, you can say our South Indian soil, which is called black cotton soil, which are kind of expensive soil. Expensive soil means when at dry condition is fine, but when you have some water or moisture uh, given to that soil, it expand. It actually just grabs those moisture to expand its volume. Some of the monzonite or bentonite body is having very high capacity. Like if you have 10 grams of soil, 10 grams, mind it, 10 grams, it can absorb a liter of water. It is having so much void space, it is having so much appetite of moisture that with a 10 gram of soil, that could be a marble shape. Hmm, that could be a marble if you have seen the marbles, uh, or even 10 grams means one or two ball bearing that you have used in cycle, that we are using in cycle. That much of volume is 10 gram of soil. That 10 gram of soil can absorb a liter of water. That means a bottle of water, and it expand. It just grab all the volume within that bottle. So this is so much. It has so much appetite for water. Hmm. So this is a very unique type of water. It's industry made. Even you can ask industries giving the composition. So they will prepare that type of bentonite and they will supply you for your particular work. Okay. So soil can be two types. One is with respect to weathering process. It can be transported soil or it can be residual soil. Transported soil means the weather rock that is product of any decomposed rock that will be transported by some of that natural media like wind, water, ice, like that, and they will be deposited somewhere else than its origin. And that type of soil which is being deposited, being formed and in a other place as compared to its origin, they will be called transported soil. Now those soil which will be deposited, weathered and deposited at its own place, they will be called residual soil, right? So two type of soils are there. One is residual soil which will be forming, which will be deposited at the same place of its parent rock, and another is transported soil which will be deposited and formed a different place, transported by natural agents like ice, water, wind, gravity, all those things, and formed at that other place than its own position, own place. Okay. So these are the two types of soil. One is transported soil and another is residual soil. There are several type of transported soil: glacial, alluvial, lacustrine, marine, aeolian, colluvial, and their actually name are given as per their transporting media. Like glacial soil, it has been the soil which are transported by glacials. Alluvial soil, which are being transported by water and deposited along the river bed or streams. Lacustrine formed at lakes. white lakes where you do not have flowing water. Marine soil, it is formed as seas, alluvial soil, which is formed by wind, colluvial soil, which is formed by landslides. Okay, so these are the soil types. Many of those your competitive exams they give some MCQ type of question from here, like the formation, the lacustrine soil is a formation of white long. Maybe the options are white lakes, seas, wind. You have to choose the correct options. So please remember this transported soil, their names and their transporting media. That is important with respect to your competitive exams. Okay. So I am stopping here. You'll be having some class with uh, Indojit, right?
Yes, sir.
Okay.
Sir.
Thank you for joining. If you have any doubt, you just put your doubts, you put your queries in that WhatsApp group, or you can directly mail me. I'll definitely get back to you with possible answers. Okay. Thank you. Have a good day.
Thank you, sir.
Thank you, sir.
Thank you, sir.